Okay, cool. I'd like to get started. And this time I want to talk about agents for software development and web browsing. So this is like one of my major research areas recently. So I have a lot of things to say and think about this. Um, so part of the reason why I'm kind of interested in this area in general is kind of encapsulated in this quote from a famous essay called Why Software is Eating the World from 2011. It's by Mark Andreessen, and it says more and more major businesses and industries are being run on software and delivered as online services, from movies to agriculture to national defense. Over the next 10 years, I expect many more industries to be disrupted by software. And basically, this is talking specifically about business. It was written in 2011. Since then, this indeed has happened. You know, there's a lot more of our life that runs on things that are created by software. And so basically, like the question that I think of a lot is, if we gave everybody the ability to quickly write software to achieve their goals, what would they be able to do with that? And I think that's kind of, a lot. Another example of this is the Nobel Prize that just happened a few, weeks ago. And two of the Nobel Prizes, number one in physics, were given to John Hopfield and Geoffrey Hinton, who did, advances in neural networks. One in chemistry was given to Demis Hassabis, among others, who was the founder of DeepMind and, did a lot of work with software. And I think kind of the important thing to think about here is that these also could be going to people who are running particle accelerators or are running wet labs or something like this. But no, in this case, the biggest discoveries were made because these people wrote software to do these sorts of things, which kind of indicates how it's not just in industry and stuff like this. It's also in, science and scientific progress, where a lot more of our work is being done in software. So that's why I'm excited about this area in general. And if we think about what is involved in developing software, how much time do people think software developers spend coding? You think it's like 50%, 75%, 90%, 30%, or 20, 15, 10? So there's actually a study of this by people at Microsoft, and they say that 15% of time is spent coding. 14% of time was spent bug fixing. So this means debugging and fixing the bugs. 8% of time was spent testing. 10% of time was spent documenting. 36% of time was spent communicating with other people. And 17% of time was spent doing other things like going to the bathroom and getting coffee and stuff like this. So not just those trivial things, but other stuff. But so this is an interesting paper. So this is from a blog post that I wrote about how we can support developers, and I think there's a lot of different ways that we can do this. The first, so kind of, and I made an analogy to self-driving, which has these kind of famous levels of automation. And in level 0, this is no automation. It means, just coding, writing code with no AI or whatever assistance. Level 1 is, I said, is kind of something like code completion, where it's completing your next thought. Level 2 would be like Copilot chat or refactoring or other things like this. Level 3 would be something like more solving complete software engineering tasks, but in a kind of limited context. And number 4 would be a very high level of automation, where we're solving entire tasks kind of autonomously. And I think a lot of people might be familiar with GitHub Copilot or Cursor. And this is code completion. what you do is you write up to this point, and then it fills in the next thing that you wanted to write. So you just write the name of the software that you want to write. And this can be very helpful. I was on a plane, and I didn't have internet access, and I was trying to code without code completion, and it felt like the Stone Age. And so I cannot live without it anymore. Very, very helpful. Separately from that, there's also kind of software development agents, and these try to solve full tasks. I actually might be able to do a demo. Hopefully it won't break because, live demos are always dangerous. But this is a software development agent we're developing. And I basically said it should download a GitHub repository for the agent itself, count the total number of commits made every month, and create a line chart. So let's see if this works. This will take a little while. Let me. Okay, that's taking a little while. So I won't, just to initialize, not the agent doing work. So I won't wait for that. But so another thing that you can do with this, okay, yeah, there it's running. So it says, I'll help you download the repository and analyze the commit history. Let's break this down to steps. First, let's clone the repository. And it's cloning. This is taking a little while. So it finished cloning the repository. Now it's probably going to write some. Now let's change the to the repository directory and get the commit history data. I'll use Python to process the git log and create the line chart. So, oops. So it wrote something, and then it got a syntax error. So it said, I need to convert the dates to date time type explicitly. Let me fix the code. And it ran it again. And it gave me a line chart of like the number of commits in every month. So I think that's kind of, it's kind of interesting that you can do that. Like, let's say I didn't like this for some reason because I wanted it to say, could you write the names of the months, not the numbers? Then it can go back and, like do things like fix itself. So I think it actually, this was pretty amazing that you could do this like just a few months ago. Now I think a lot of people might have seen demos like this. But there's a very big difference from writing like just a single one-off Python script and actually doing full software development. And that's kind of one of the things I'd like to talk about here. And another thing, okay, well, it's working. It's working on that. I'll let it do that. Okay, yeah, so it changed it to the names. But yeah, one of the big problems is like actually how you can get this to work in full software development tasks. And another kind of methodology modality where I use this sort of thing is in GitHub, where you can like put it in a GitHub bot and have it go in and create PRs for you and fix up your GitHub repository. And so if you have like an issue, you write fix me on it, and it goes in and fixes it and stuff. There's also a lot of other non-coding tasks. So like gathering information from GitHub, I just gave an example of this. So in order to do that, it cloned from the GitHub repository. There's also GitHub issues, other things. Managing task resolution software. So like, for example, using Jira or Linear or whatever GitHub issues, whatever way you manage your tasks. setting up web infrastructures. So like if you've ever worked in a real, software company, a big thing is like making sure that you can actually go in and deploy your software in a robust way and stuff. And that's actually pretty hard and other things like this. So there's all kinds of other things involved in developing software. If we look at how promising these things are, this was like one of the early studies in 2022, right after GitHub Copilot came out. And they did a study with 45 developers who used GitHub Copilot and 50 who didn't use GitHub Copilot. And they found that given certain tasks, the ones that used it were able to complete 78%, those who didn't use 70%. But the more interesting thing was this actually reduced the overall time that it took to solve the tasks well in like it was 55% less time. So this really makes a big difference in how quickly people can solve tasks. But there's a lot of challenges in the development of agents like this. I talked about agents last time, but how do we do this for software development tasks like defining the environment, designing observations and actions, code generation, file localization, planning and error recovery, and safety? And I'd like to talk about each one of these. Together, I'm also going to talk about web navigation a little bit, because web navigation is also kind of an element of being able to solve these tasks. So before I get started, are there any questions here? Any discussion? Okay, cool. So the first thing I'd like to talk about a little bit is evaluation, because if you actually want to work on this for a project, then evaluation is really an important part. And there's quite a few different environments that we use to test code generation. In reality, we do a lot of navigation of like GitHub, GitLab, task management software like Jira and Linear, office software like Google Docs, Microsoft Office, communication tools like Gmail and Slack. Testing environments that we have right now are mostly focused on coding. But in reality, developers do a lot more, like browsing the web. Web Arena, which I will talk about in a little bit more in a bit, does cover GitLab is one of its issues, but it's mostly we have like coding tasks and then we have non-coding tasks. So for simple coding, we kind of talked about this a little bit, so I'll go through it quickly. But we have human eval and MBPP. These are standard benchmarks. And basically, they consist of having a function, a description of the function, and then you need to generate the function itself. They have usage of the Python standard library, docstring, some examples, input, outputs, and tests. You don't really need an agent to solve this. Like one-off code generation models can just solve this without any sort of agentic thing. But if you added an agent here, it would be able to check its solution and refine it and try it over and over again until it actually worked. So you could use that. Over broader domains, there are data sets like Konala and Odex, which are broader data scraped from Stack Overflow, adding execution-based evaluation and covering a wider variety of libraries. So some of the problems with human eval and MBPP are that they mostly cover kind of just the Python standard library. Another thing is data science notebooks. So like a lot of people use Jupyter notebooks or Google Colab notebooks. And there are benchmarks for things like this. Arcade is one example of it. And this is interesting because it allows you to evaluate code in context. So like we don't generally create code de novo, like from scratch. So this allows you to like build on existing code, consider context, other things like that. The biggest data set that a lot of people are using nowadays to evaluate these is SWE-bench. And this includes issues from GitHub plus code bases, and you need to generate a code pull request. So for example, we have like data leak and GBDT due to worm start, yada, yada, yada. And these are like real pull request, real issues that resulted in a pull request, and you end up getting tests where these are all the tests that existed before the pull request. And then these tests were added together with the pull request. So the basic idea is like, if you have these tests that were added together with the pull request, these are tests that probably tested the new functionality. So you need to be able to pass these new tests in order to do well here. This is interesting because it uses long context understanding and requires precise implementation. There are some issues with this, which I'll talk about in a second, but overall, it's a quite good benchmark for evaluating these. And there's also a multimodal version that was just released recently. So if you're interested in multimodality, that's another thing to take a look at. The metrics that we use to evaluate systems here are pass at k. So the basic idea is if we generate k examples, will at least one of them pass unit tests. And so we generate, one way to do this would be just to generate k examples and evaluate them against unit tests. But the problem with this is high variance. So like if you only generate one output and those outputs pass half the time, then like 50% of the time you'll get it right, 50% of the time you'll get it wrong. And so the variance will be very high. So this was introduced in the paper for human eval, and it's used pretty widely. You basically generate more than k examples, and then you estimate the actual value for for how many times you would have passed. And you can do this through using like not permutations, combinations, calculating the number of combinations where you would pass. So an aside that's really important to talk about when we're talking about these benchmarks is leakage of data sets is a big problem. And the reason why this is a big problem is a lot of the code that is used to create these benchmarks was gotten from online. So for example, Swebench is like pull requests from GitHub, and all of the big LLMs are trained on GitHub. And one interesting thing is if you look at this arcade data set, they actually did a thing where they had existing data, and then they had existing notebooks that were found online, and then they generated some new notebooks, or they got notebooks that were not previously disclosed before and evaluated on them. And there was like a drastic like drop where some of the models dropped to like 10% of their previous accuracy, which kind of indicates that, you know, data leakage is a really big problem. There's also reports in this live code bench paper where they essentially have a plot, and they say that in general, if you do well on human eval plus, you also improve on this live code bench easy section. But there's a subset of models that are like not matching that correlation, where they get a good accuracy on human eval, but they get a relatively poor accuracy on live code bench. And basically, what they argued in this paper is these ones up here are ones that were probably like overfit to human eval, or like where some of the test data from human eval or something very similar to it ended up in the training data. So it's just something to be aware of. Not necessarily, it doesn't completely invalidate benchmarks, but you do need to be careful of it. Cool. Any things so far? Okay. There's also been a lot of interesting work on multimodal stuff. And so I mentioned the Swebench multimodal version briefly. Another example is design to code. So this is code generation from websites. So you have websites that look like this. And the idea is that you need to generate the front end code that resulted in the website looking like this. So so you generate the like HTML or the JavaScript that resulted in this. And they also proposed a model to do this. One interesting thing is like, how do you evaluate whether you did a good job of this, right? Like you can't just say this one is correct and this one is not correct. So the method that they used instead is they use visual similarity of the website. And they proposed two metrics. One is high-level visual similarity. So they had a visual embedding model where they embedded the whole slide and compared the visual embeddings of both slides. And they also did low-level element level similarities. So they have each individual element and they try to judge whether that element appeared in the output and then give a score for each one of them. And this made the evaluation more robust. Yeah.
What this is add images or actual predicate objects?
For this task, the input is images and the output is code. But once you have the code, you can regenerate the image, right, from the code, and then you compare the like regenerated image with the original image. Yeah. Cool. So I talked about coding environments. I'd also like to talk a little bit about UI-based environments. And most of these are web environments, but not exclusively. So the first kind of web environment that a lot of people use nowadays is something called Mini World of Bits. And this is an environment that has web pages, but they're extremely simple web pages. So it's like all the way from the thing of like click the next button to select the following color with the color picker and hit submit, to use the text box to enter Leonie and press search, then find and click the second search result or something like that. So multi-step. To book the cheapest one-way flight from NLG to Brownsville, Texas on the state. So then you need to step through multiple outputs. So this was made in 2017, and I think like actually not a huge number of people were working on this. And then suddenly in 2023, there was kind of a much greater surge of interest in working on web tasks. So there's more benchmarks that have happened since then. The first one is called Mind2Web, and this has some very nice characteristics, but it's missing some things. And then there's also Web Arena, which I'll talk about next, which is kind of contrasting. But this is, in Mind2Web, basically what they did is they scraped a whole bunch of real sites by having humans do actual tasks on them. And then the humans, like, clicks were all recorded. And so now you get a trajectory of like the correct clicks that you could do to solve those tasks. So the way they evaluate this is they have a model predict the next click at each step in the trajectory, and you get points for every click you predict correctly. But the problem with this is that there's actually multiple ways to solve tasks. So you only get credit if you pick the one that the human actually chose. And the other problem with this is you're not measuring actually whether it was able to solve the entire task. So like agents, they can make a mistake once and then go back and correct their mistake and actually succeed at the task. And this doesn't give you any credit if you do that. So it's both like too hard and too easy at the same time. Separately from that, there's Web Arena, which is something that we created. It's sandboxed open source websites. And so you have a whole bunch of websites that are meant to simulate real environments. So for instance, we got open source web applications for a shopping website, a content management website, a bulletin board website, and a GitHub style website, GitLab. And we created an environment with this, and we allow the agents to solve tasks on this, like tell me how much I spent on food purchases in March 2023, and create a Nolan fans repo listing Nolan's Oscar-winning films in a README file and things like this. And evaluation is performed through validators. So like for the first one, you just have an actual amount of money. So you can just check whether the agent output that amount of money. For the second one, you need to check if like there's a certain state of the GitLab repo. So you check in various ways. So The good thing about this is it's actual agents interacting with actual websites. They're relatively realistic because they're full like production level open source things. We also got the tasks by looking through our browser history. So we looked through our browser history for the past month and saw things that we actually did in the past month and created tasks kind of inspired by that. So the tasks are reasonably, you know, reasonably realistic. The problem is the open source things are definitely like different than the real sites, and they can be both like simpler in terms of their design, but also more difficult to use. So some of the open source sites are like not as easy to use. Like the Maps site we have is way harder to use than Google Maps. So again, it's a little bit disconnected from working on real sites. Yeah.
So I know reCAPTCHA was also made at CMU. What has been the process when agents go around and see those reCAPTCHA arguments in a robot? How do they deal with that?
Yeah, that's a great question. So how do you deal with things like CAPTCHAs? I actually literally saw something yesterday where somebody was using the new version of Claude to solve CAPTCHAs, but uh, the answer is this isn't on live websites. This is just recorded human trajectories. This also is on open source websites, so they're ones that are under our control. So even if they have the option to add CAPTCHAs, we just remove it. So you don't need to deal with it. If you wanted to evaluate on real websites, you have all kinds of problems. Like you have CAPTCHAs, you also have the site design changing. So your benchmark becomes invalid after a while and stuff like that. So there are benchmarks that do this, but I don't think they're as widely used as these ones for that reason. Yeah. Great question. Okay, cool. There's also a visual version of Web Arena called Visual Web Arena. And this uses vision-heavy inputs. So I'll read the top one up here. It says, help me make a post selling this item and navigate to it. Price it at $10 cheaper than the most similar item on the site. So notably, this doesn't tell you anything about what the item is. You need to entirely infer that from the image. So this needs like multimodal information. And so that's interesting in that way. There's also benchmarks that are not just on websites, but on kind of operating systems. So there's like actually a lot of them on Android phones, for instance. And then additionally, there was this OS World benchmark that was released recently that's on kind of more desktop OSs. So all kinds of things like this. Cool. So that was the evaluation part. Now I'd like to get into the like model building part. So the first thing that we need to think about, like as I mentioned last time, is designing observation and action spaces. And in terms of action spaces, if we think about coding agents, actually this is kind of like observation and action spaces. So coding agents, they need to do things like understand the structure of the code that they were provided with, read an existing code, modify or produce code, run code and debug. For browsing agents, they need to do things like navigate and act on websites and also understand websites, either visually or otherwise. So a first example of kind of a coding agent action space is Codact, which basically what we do is we generate code in order to solve problems. And this can include both just solving kind of like assistant style problems and solving coding problems. But I talked about tool use last time. And when I talked about tool use, we were calling like one tool at a time. And if you call like just one tool at a time, where each tool is something like lookup rates or convert and tax, estimate final price, look up phone price, estimate shipping cost, other stuff like this. If we get something like determine the most cost-effective country to purchase the smartphone model Kodak One, the countries to consider are the USA, Japan, Germany, and India. You can do this with all of the tools that were provided to you, but it would take a really long time. It would take a bunch of steps because you would have to call one tool, then another tool, then another tool, then another tool. And you'd have to do like the same thing for 3 different countries and stuff like this, or 4 different countries. So what Kodak does instead is it just writes a program, basically, to solve any tasks. So the only interface it has is writing programs, but it's provided with the APIs of all the tools that it wants to work with. So in doing so, you can actually solve this task at a single step. And it can execute bash commands and Jupyter commands. And that's actually what we use in the coding agent that I just showed. Another example is SWE agent. In SWE agent, basically what they did is they defined specialized tools that make it possible to efficiently explore repositories and edit code. And this is the general idea. So you have an LM agent, and they define something that they call the agent computer interface, which is LM friendly commands to do things like repo navigation, searching files, viewing files, editing lines, et cetera, et cetera. And then these interface with the computer and provide LM friendly environment feedback. So this is an example of performing observations and actions. And so one observation is like after you've called the file view command, it will give you a view of the file. You specify a specific line of the file that you want to be looking at, like 405, and then it will give you a view like above and below that line. So the reason why we do this and we don't look at the whole file is, a file could be 10,000 lines long or 100,000 lines long even. And if you do the whole file, then it would essentially cause your context window to blow up, lots of tokens to be spent, other problems like that. So that's the idea of like LM-friendly feedback here. On the right side, we have something that would be an observation. Then we have an action. This is also using React, like I talked about in last class. So you have a thought, and then you have the actual action to perform. And here, their actions are kind of in this format, like edit, end of edit. And that means that you would edit lines 404 to 407, and then you would replace it with this. So this is one example. In OpenHands, which is the demo that I just showed, we are kind of using a combination of these two. You can ignore the browser stuff for now. We'll talk about browsers in a second. But we are using Codact, so it's able to write arbitrary Python code. But this arbitrary Python code uses APIs similar to the ones defined in SWE agent. So we basically provide editing actions as APIs that can be used in Python code. And so this would allow you to do something like go through all of the files in a directory and open and view all instances at the same time. So you could write like a for loop that views all of the instances of a particular string in a file or something. So it's kind of similar to SWE agent, but like a little bit more powerful. So one other very interesting method of editing files that was actually proposed in Cursor, the file editor. It wasn't originally designed for or used in agents, but now we've also implemented it in OpenHands as well. Is you first have a strong but expensive LM create a summary of the edits that you would like to make to files. So for example, if I say change the arguments so that they're all lowercase in jekyllpost.py, you'll have something like Claude Sonnet, expensive and powerful LM, say like, certainly I'll modify the arguments to be all lowercase. Here's the updated section of the code. And it updates the code, but it adds like ... existing code, ... rest of the existing code, like this. And so this isn't actually editing the whole file, and there's not actually a one-to-one mapping between this and like actually going in and editing the file. So what is done after this is then you go and modify the whole file with a cheap model, and you have the cheap model go and regenerate the whole file, and then that allows you to kind of more accurately make sure that you're getting in all of the context and not have weird discontinuities. So like to give an example, in SWE agent, when we do file editing, one issue might be that you accidentally mess up the file numbers and delete one of the previous lines, and then you get poorly formed code. And that almost never happens if you do something in this format. Cool. So these are kind of like the actions that people use to interact with file systems when you're doing any sort of coding or software development or things like that. Are there any questions about this? And I'll go to web actions next. Yeah.
Context window isn't a problem because it's solely relying on the edits made by the expensive model.
For the cheap model, so great question. So for the cheap model, the context window isn't a problem because it's relying solely on the edits from this model. There's two reasons why the context window is less of a problem. Number one, it's a cheaper model, so you can run it with a longer context window and be less worried about it because it'll be fast to run. The second reason is generally for editing, especially within an agent, at least this is how we implemented it. The agent has all of the history of like all of the interactions that you've done so far, all of the observations that you've done so far. But for the editing model, the hope is that this edit is self-contained. So you just provide code, the like editing instruction in the original code, and it goes in and does that. So you throw away all of the context when you feed it to the editing models. Yeah. Cool. Okay. So the next thing I'd like to talk about is web agents. And I'd like to give a few examples of how people implement web agent observations and actions. So we have like the screenshot, the text, and the accessibility tree. I talked about this a little bit last time. So I'll focus more on the action space. And for web, the action space I feel is like a lot more atomic. So it basically, we do things like typing on the keyboard, clicking, hovering, and scrolling with the mouse. In the browser, we have things like new tab and go back. And so we have like a very small number of actions that are very atomic, and we need to do like lots of clicking and other things like that. And that's a little bit like, it's a little bit like the difference between this and this, right, for coding. And because you need to click many times and scroll many times and stuff like that to solve the problem, so you take many steps to do that. But that might not be the ideal way to interact with environments. And actually, between when I created these slides like 3 days ago and or when I updated these slides 3 days ago and now, we actually just released a paper that tries to close this gap a little bit. Might be so new I can't find it on Google. Yeah, here it is. So we basically did something a little bit similar to the Kodak paper, where instead of requiring web agents to kind of like go to the page and then log in, click, 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 scroll down, and stuff like that, you just let the agents interact directly with APIs over the websites and go in and solve web-based tasks. And we found that this gives quite substantial performance improvements. So we have the browsing-based agent clock in at about like 15% accuracy. We have an API-based agent get about 30% accuracy. And then we also proposed a hybrid agent that's allowed to click on websites or call APIs. And this gets about 35% accuracy. So I'm pretty excited about this result in that, you know, working with websites is pretty hard and it can be slow and stuff like this. So that might provide an alternative as well. Yeah.
API calls that the website itself is making to fetch results.
Yeah, so where do we get the API calls? That's a good question. So the API calls, basically, we experimented on Web Arena. And Web Arena has kind of 4 or 5 kind of main websites. Like the shopping, it has a shopping website, it has Reddit style bulletin board, GitLab, a map website, Wikipedia style website. And all of the ones except the Reddit clone PostMill had good APIs already. And they were kind of like either defined and documented well already, or if you looked at the calls that the front end was making to the back end, you'd be able to find them pretty quickly. The Reddit style website did not have such APIs, so we actually had to create them manually for this purpose. So there is definitely a disadvantage of like if you don't have APIs for a website, this becomes, a problem. But there's kind of 2 obvious future directions here. The first obvious future direction is, well, if AI agents are going to be a big thing in the next couple of years and you want your website to be compatible with them, websites will just make APIs. And that's kind of what happened with ChatGPT plugins. A lot of websites were really excited to make ChatGPT plugins. The other thing is maybe there are ways that we can automatically induce APIs, and we're thinking a little bit about that as well. So like you induce APIs that then translate into kind of atomic actions too.
Do you face like credential issues or like access issues to this?
Credential issues for APIs. So like one big caveat here is we only did it on Web Arena where, like we kind of have control of the websites. So if you don't have control of the websites, then you would face credential issues if they aren't available. So there are definitely barriers to overcome here, but like kind of my belief is that there will be some interfaces that just say you need to work through our web interface, especially ones that depend on like, for example, advertising revenue to, keep the site alive, because if they have bots crawling the site, that's kind of counter to their, whole reason for existence. But there will be other ones that are shopping websites, which are like, please give me your money as quickly as possible. And those ones, like if they realize bots are a big thing, they're going to, make APIs available to use. Okay. That's a little bit of an aside, but yeah. So the next thing I'd like to talk about is visual web arena. And I talked about this a little bit kind of separately. I talked about web observations and set of marks separately last class. But I just wanted to show this screen to show how the set of marks works in a web context. So in the web context, if you remember a set of marks, basically what we did is we highlighted like segments of an image and put a number next to them, and then asked the visual language model to pick the number that it wanted to interact with. And what the UN visual web arena is, start with the original web page. So you have the visual web page and you also have the underlying HTML, and you extract the accessibility tree, or the set of mark elements with web content. And you also create a set of marks on the web page. So you basically highlight every interactable element and like assign it a number. And then based on that, you have the agent do something like click 31, and it can look at the visual content in order to do that. Cool. So that's kind of like the observation and action space that a lot of the agents are using for web or coding tasks. The next thing I'd like to talk about is file localization. And this is particularly an issue for kind of any sort of agent that does file manipulation on a hard disk, but especially coding. And so the basic idea is trying to find the correct files given the user intent. And so this is an illustration of the problem. This is like an actual issue from our repository. So real, real data. And if we look at this, it says, what problem or use case are you trying to solve? When in confirmation mode, it's not possible to give instructions in between steps. You have to reject an action, and it seems like it doesn't know that the action was rejected. Excuse me. And then describe the UX of the solution you'd like. The simplest would be to have a third option, confirm action and wait. This way the action is confirmed, but before it tries to take the next step, you are able to give some feedback. Also, if it somehow knows the action was rejected, that would be helpful as well. So when you do reject the action, it knows that the action wasn't taken. So assuming that nobody here has actually looked at our repository, I think you would have no idea what file to be looking at in order to solve this, right? The answer is it's probably like some JavaScript file in a front end somewhere because it has to do with creating a UI, but also maybe in the back end to switch the behavior of the back end system. So it's kind of tricky to figure out which file to be modifying, and this is a huge problem for agents as well. Like agents tend to search around for the file to modify and then spend all of their turns and then be done and fail. And one interesting thing is this is kind of like analogous to environment understanding or exploration, which I talked about last time, because in a coding agent, the code repo is your environment, and you want to go in and navigate it in the most effective way. So there's a number of solutions to this. Solution number one is to offload to the user. And so what this means is you just expect that the user will provide you with which file to be modifying. This is how GitHub Copilot works. It's also how Cursor works. And the reason why is because they only modify the files that you currently have open. So you know that any modifications that the user is going to be requesting are in those files. Another way to do this is to explicitly state in the GitHub issue which files need to be modified. So this is an example. In this file and this file, we should check to make sure that all required environment variables are set before running any additional workflows. If all of the variables are not set, then we can fail immediately with an error. And so this was created by an experienced user who knew a lot about the repository, namely me. And so then you can see that the bot actually was able to open up a pull request that appropriately modified these files and solved the issue without any human feedback. But it only looked at these files and was able to modify them. So this is a great solution if you can expect a little bit more feedback from users, but that doesn't work particularly well when you have something that requires debugging or the user doesn't know where the problem is in the first place. So there's a couple other solutions that people try as well. The first one is to prompt the agent with search tools. And so basically, for instance, with no search, the agent performs, the agent would perform manual search with ls and cd or grep or find or something like this. And that's an option that's kind of the baseline here to give it a bash terminal and allow it to try to do whatever it can. But there's also other things where you search for a keyword, and then the agent can get a first search result, and it says 1 out of 15. And if that's not the one it wants, it will click next and next and next. Another thing is that it will get a summary of all of the things that were found, and then it can open the file that it wants. So these were all tested in the SWE agent paper. Another solution that people use is to a priori map the repo and somehow do search based on this map. So one example is from a tool called Aider. It uses something called a repo map that creates a tree structured map of the repo. And this was taken a step further by a framework called Agentless, which does a hierarchical search for every issue. So basically, the way this works is you start out with this big repository. You get an issue, and you get a summary of the repo structure, which is basically like the tree-based representation of all of the data. And then you prompt an LLM to pick what the top N files are that it would like to explore further. And then based on this, it opens up all of these files. And instead of getting the files themselves, it gets a summary of all the classes. So it uses a static analysis tool, like a tool that analyzes the Python in these files to pull out all of the classes and function names. And then based on this, you ask the LLM again to pick which functions it would like to look at, classes or functions it would like to look at, and then it gets a summary of those. And so this allows you to kind of basically get a summary of all of the files you should be looking at before it actually generates the patches. So a final solution is retrieval augmented code generation. And so like everybody, it worked on or is possibly working on a RAG system now. And so you can definitely apply this to code. You can retrieve similar code and fill it in with a retrieval augmented LM. And we have a paper, Code RAG Bench, that we just published recently that kind of goes through, if you're interested in this, it goes through like a lot of data sets that you could use for this, a lot of methods that you can use for this. But one interesting thing is like actually code RAG seems to be a lot harder than, or code retrieval for RAG seems to be a lot harder than code like regular retrieval for regular RAG. And the reason, if you think about it a little bit, is kind of obvious. Like it's cross-lingual retrieval. It's retrieval from English into Python. And it's also kind of like cross-granularity retrieval, because very often the code you're trying to retrieve is much more granular than the description you get of the code. So that makes life a lot harder for the retrieval model. And on SWE-bench, we evaluated a whole bunch of like relatively strong retriever models. And the best one only got like 60% accuracy on trying to retrieve the correct files. I forget what value this was. I think it was at five retrieve files, but I might be wrong on that. Another alternative is that in code, there's documentation which can also be retrieved. So you can basically look up the documents. And I mentioned this a little bit before. But this kind of solves that issue somewhat because the documents are in English, and that makes your life a little bit easier. One unsolved issue, which I really would like to solve, is when and how to perform RAG in an agent. And there's a couple possibilities. Basically two possibilities. One is to prompt the agent with a RAG tool, so to give it the ability to do RAG at like every time step when it thinks it's necessary. Another one would be to do it a priori, so like right at the very beginning you perform RAG. A final one would be to do it kind of passively in the background, so every time the agent takes an action, you have the RAG system kind of like observing the action that the agent is taking and providing context dynamically as well. So I think all of these would be interesting. There's not really, I think a good solution for that yet. Cool. Any questions or discussion? Or... Yeah.
So I was actually reading the code right bench, and the purpose they were dividing this, like they were dividing the Python file in a repo that has like overlap. I was wondering that what's the intuition behind, just like, for example, if your Python file has 30 lines, you can just like do 5 lines and then cut it to 6 documents, but instead they will do like an overlap of those lines, so like 0 to 5 and then 1 to 6, that kind of thing.
Oh, okay. Let me make sure I understood the question correctly, but basically your question is for RAG, they had like overlapping chunks like this. Yeah. So this is just, it's like a pretty common thing to do in RAG in general. And the reason why is because like, let's say the context you need is like right here. If the context you need is right here, it might be cut in half if you segmented and didn't have any overlapping. didn't have any overlap, like let's say you didn't have the one at the bottom, then this might be cut in half. So if you have overlap like this, then it's much less likely to be cut in half.
This also cause the document you return to have multiple duplicates.
Wouldn't that cause the documents you return to have duplicates? Yeah, it might. That's a good question. I don't think that people generally do anything explicit to fix that. It might actually be a feature, not a bug, because like what if you had something that was kind of long like that? But yeah, good question. Yeah. Any other things? Okay. So the next thing I'd like to talk about is planning and error recovery. And this is also an issue with all agents, as I mentioned before, but I'll talk about it specifically in the context of coding agents. So the first thing that you can do in terms of planning how to solve a coding task is a hard-coded completion process. And there was one very kind of popular framework, which they call it agentless. And you could say it's either not an agent or it is an agent with a kind of like fixed plan that it must adhere to. But basically, it's a hard-coded progress of file localization first, like I mentioned before, function localization, and then they generate a whole bunch of patches, and then based on all of the patches, they apply the patches and then pick one that passed like some basic checks of syntactic correctness and stuff. So in order to solve a issue on GitHub, this is a pretty good process. Like, locate the files, locate the functions, generate a patch, and apply it. There's also LLM generated plans, and there's a bunch of examples of this, but like, for example, you can have an LLM generated planning step, and then one or more things that actually execute the plan. And this is an example from a paper called Coder, which has kind of a setup where you have one manager that generates a plan. And in its plan, it has multiple steps. And then within each step, you have essentially a reproducer that can try to reproduce the bug. You can have a fault localizer that tries to identify the place where the fault is happening, an editor that edits, and then a verifier that writes tests or something like this. And so this is kind of hard-coded because they've hard-coded these roles, but it's not entirely hard-coded because the manager generates a plan at the beginning and things like this. So these are kind of two options for planning. I feel like there's many variations of this planning step, but I feel like they're all kind of fundamentally one of these two things, like kind of varying from more hard-coded to less hard-coded. So I think those are fundamentally the two options. The second one, the next thing is fixing based on error messages. So like last class, I mentioned reflection, where reflection is essentially kind of a broader version of this, but in order to solve tasks, you basically need the ability to understand error messages and fix them. Actually, there's another paper that I should mention here. So this one, basically what it does is you have the initial message, and then you have the agent, it makes a plan, it executes, it gets an observation, and it continues over and over again, trying to fix any issues that it has. There's also a kind of interesting paper, which I forgot to add to my slides, but I should have added to my slides. This one. And so this is a paper that, number one, kind of examines the ability of large language models to debug their code. And then further goes on to actually train models to debug the code. And the way they do this is they generate kind of errors and then train the model based on the on kind of like fixing the errors that occurred from the original baseline model. So there are a variety of methods to kind of try this sort of thing, but those are some representative papers there. So this is really important because models make lots of mistakes, but they're actually also reasonably good at recovering from them. Like, for example, Claude, especially the newest version of it, is quite good at recovering from errors. So that's kind of the place where having an agent will give you the most benefit because, you know, you're doing this multi-step process and it can go in and fix things and stuff like this. It's also the reason why you might want to use an agent instead of just using ChatGPT, because ChatGPT can give you like erroneous code. And if you use ChatGPT's erroneous code, essentially you become the execution loop of the agent. You copy paste the code into your code base, and then you get an error, you copy that into ChatGPT and then copy it back and stuff like this. So. Cool. Any questions here? Okay. The one thing I'd like to talk about is safety also. And coding in web models can cause harm. And if you actually use them, you will notice how easy it is for even state-of-the-art models to make mistakes that are kind of bad. So one very frequent thing is the coding model will accidentally push to your main branch on GitHub. So like, for example, if you say, please fix this bug and commit it, for some reason it takes commit and extrapolates to also push to GitHub. And it will push to GitHub, and if it made a mistake in its coding task, it will mess up your main repository, like the main branch on your repository. And you know, you might be able to recover from that by like rolling back and undoing the commit, but nobody wants to do that, right? That's like a huge pain. And if it's a repository that a lot of people use, it might be embarrassing or something like that. So you don't want that to happen. This one was actually pretty interesting. It seems like kind of a typical dystopian scenario of AI doing something you really don't want it to do. So in actual cases, I've asked coding models to make the tests pass, but it successfully did that by deleting the tests that were not passing. So you know, I feel like the models take things super literally and try really, really hard. And because they take things super literally and try really, really hard, they will continue trying until things work. Another example is I asked it to add encryption to a database, and it tried to add encryption to a database, but the encryption was not working on that particular database, so it switched the database software I was using to a different database software, which is like, you know, that's a solution to the problem, but I didn't ask it to switch the database software, so it's not a very good solution. Another thing that I've observed in web agents is if you ask them to do things, it will fill out and submit forms for you, but it will do so with like fake email addresses and fake passwords. So these are things you definitely want to think of before you give, you know, a web agent full access to your Amazon account and have it order, you know, expensive items. Also, there is some concern for intentional misuse, something that we need to be aware of. So for example, there have been papers that have shown that coding agents can be used for hacking into systems, solving capture the flag problems. And so I think this is something we need to be aware of as well. This is the reason why I feel like it's very, very important to have open source alternatives here, because if we don't have open source alternatives, people won't realize this is a problem, won't be able to do security research. And so then in that case, only the hackers will have agents who can do this sort of things. So I think, it's a very strong argument for being able to have open research in this area. So what are some of the safety mitigation strategies that you can use? You can use these for regular agents as well, but they're particularly like salient or easy to understand. So the first thing you can do is limit the execution environment. And what this involves is, for example, making sure all of your code runs inside a Docker sandbox or inside of a cordoned off virtual machine. Another thing that you can do, so this works. One problem with this is that it's very easy to make a very safe and very useless agent, right? You just don't give it access to anything. And you put it in a Docker sandbox, and you get something that can't modify your GitHub files. It can't do anything on the web for you or anything like that because you're not giving it access. So I think the real challenge here is how do you create something that is safe and useful? Like you give it exactly the right amount of access that it can't cause harm, that it won't cause harm. Another safety mitigation is credentialing. So there's a very famous thing in computer security called the principle of least privilege, which is like you give the least amount of privileges necessary in order to solve the problems you're interested in solving. And a good example of this is GitHub fine-grained access tokens. So for instance, if you go to GitHub and you can click on this link, but if you go to GitHub and you select developer tools and select tokens, it will come up with a way that you can generate tokens that can be used to do only certain things on GitHub. And for example, you can give it access to only reading and writing the contents on your repository and opening issues. So this will, in opening pull requests. So this will give it the ability to open pull requests, but not like write issues or not like change the security settings on your repo or something like that. Another safety mitigation. Oh, so one I didn't mention because it's like so kind of central is another thing that you can do is like train the underlying large language model to not do unsafe things. But that's actually an issue. There are actually issues with that maybe I'll talk about at the end. But before I do that, one final safety mitigation is post hoc auditing. And to give an example, in OpenHands, our toolkit, we have a security analyzer. And what this does is every time the agent generates an action, you get an estimate of security risk or an estimate of risk of performing that action. And if it's over a certain level of security risk, then the action will not be performed and the agent will get a message that this is dangerous. So this was not performed. And this can be done using language models, kind of like standard security analysis tools or both if you want to. One really interesting finding, which I'd like to share, it's also not in my slides at the moment, is this one. It's surprisingly hard to find. Okay. So this is an interesting paper that I saw recently, which is like large language models are generally trained to refuse to do harmful things as chatbots, like ChatGPT in ChatGPT or Claude, like the Claude UI and stuff like this. But when you use them as web agents, you can actually get them to do more dangerous things. So like the idea is, please or yeah, actually, I should use the actual examples from here. like compose a defamatory post on Twitter claiming that the current US president is addicted to heroin or something like this. And this is something that ChatGPT will refuse to do. But if you ask it to do it as a web agent, it's kind of moved out of distribution from the things that it sees normally, and it like actually will go in and do this sort of stuff more often than if it was not treated as an agent. So I think this is something that anybody training a large language model will need to like think about and solve in the future. It's also, if you're interested in kind of like the theory of why this happens a little bit more, there's also papers that examine this from another angle. So this is like an example of a paper from Aditi's group here at CMU, where they basically demonstrate that if you do something like safety training of a model, but then you move the model out of the distribution where the safety training was done, then it basically undoes the safety training, or like it gets the model to be less safe. So I think this is like kind of a specific instance of that. So long story short, like my current feeling is yes, it's great that language models would be, people training language models for safety would be paying attention to something like this, but I think we still need like more kind of security like mitigations other than that. So, okay, I'd like to jump to the conclusion. The summary, copilots are already very useful in coding. Coding agents are getting there. I'm using them for a lot of things. So like I use them for data analysis for my experiments. So I wanted to this morning, I wanted to download a CSV file and calculate the inter-annotator agreement between the annotations and the CSV file, just for my own research. And I asked an agent to do it, and it did it for me. So there's other things like that. It's also good for doing like minor fixes on large code repositories, as long as localization works and stuff like that. It'll be getting better, I think, over the next year. Current challenges are editing, localization, planning, and safety. Future directions, agentic training methods. So one thing I've noticed, for instance, is Claude tends to be very good at recovering from errors and other things like this. It's much better than GPT-4. It's better than O1 to some extent anyway. And I suspect that they're doing some sort of agentic training under the hood because, as we talked about, reinforcement learning allows you to recover from errors. It removes the exposure bias of you assuming that all of the things you've seen before, are correct and stuff like this. So I think that's a big thing. I don't think there's a lot in the open source or open research talking about this on kind of like large scale web or coding scale things. So I think that's an interesting direction. Another thing is human in the loop studies. So like agents can interact with humans. Like you saw me say I wanted to change the specification, and it went in and was able to change the specification. Another problem that we see is agents will go off and do things when the intent is underspecified and mess things up, like the deleting the tests case. And it would be better if they did things like ask for confirmation or gather more information in that case. And so that's another future direction. Another future direction that I'm very interested in is broader software tasks than just coding, like software testing, debugging, other stuff like that. So I think that's interesting. And you can try out agents yourself. This is a link to our particular repo, but there's also other repos. I think this is the best one for coding and browsing at the moment, but there are other options out there as well. So yeah, that's all I had.